My name is Jacques Matthew. For my database project, I'm taking a look at the AllMusic.com, and I'm taking metadata from multiple songs, parsing it from the raw HTML, importing it into CouchDB. Here's my CouchDB database. With that, I'm trying to predict the length of a song based on whatever factors accurately affect that. So first of all, an example of the data in its raw form looks like this. So this is just your standard HTML for a page like this, which is a song page. Here you have the song name, everything else, artist, album, year, label, time, AllMusic rating. And then also over here, you have the song genres, the styles, moods, and themes. And more of that can be found in the attributes page. Now, what I do in my Python program is I parse that data and I then upload that to the database. So an example of that would be, this is the one we were just on. This is the Papa Roach song. And so my function basically parsed that information from the raw HTML and put it in this format. So it got the artist, the link to the artist's album, label, time, year, you name it, it has it. And it also has the raw HTML. And to do that, you click JSON, that's just the raw JSON, and you type /page, and that's actually what we have right here. This is a code that scrapes the raw HTML data from allmusic.com and then uploads it to CouchDB database. So first I have this small package that I made called MyCouchDB. It just basically sets up the database so I can refer to it in my code really easily. And here are the few functions to help me retrieve documents from the database to use elsewhere in my code. Next is my web scraping code. This is the code that downloads the HTML, given the domain and the subpaths. It will download that. This gets any attachments from CouchDB database, so that's just getting the raw HTML. This gives you the genres from each genre page, and from that, create docs from genres page links. This works fine. The only downside was that it produced a small data set. So I decided to go and do a different technique that produced a larger one. Ended up doing, I made this web crawler function that basically just looks at every single link on every single page, creates the doc from that HTML. But for example, I'll run some code. So right now it's downloading the HTML from the link we passed in. Here it found all the links on the page. And now it is traversing and looking at the first link it has not traversed before from those links that I found on the page. So there's the document ID. So this is getting the metadata. So this is actually going to the attributes page. So it's also downloading more HTML and it spits out all this stuff. And from there it goes and looks at all the different links on that page, adds the links from before that weren't used to the current link count, and then it goes on to the next song or link it has not traversed yet. To prove that this was added to the database, I'm going to add the ID that we got before, run query, there it is. And this one, as you can see, it didn't have anything in the attributes page. So just to show that, we're going to go there. See, it didn't find any song genres, any styles, or anything like that. So from there, we can do the data analysis. Unfortunately, I wasn't able to get Python to really run the stats models API, but I will show you the little things I did do. This is some basic data analytics. Well, first off, I was able to save the data from the database to this CSV file, which is how I got it both into the pandas data frame and of course the R data frame. First, I'll run this to show that it does save to that, and I'll get rid of the file. Now let's run it. Okay, so what this is doing is going through each document in the database and checking to make sure that it has the subpath key. If it does not, that means it's not a song document. Now it's saying it's parsing all the data as it is, and that means it's parsing all the data, getting all the values for the fields and whatnot. And now it made the CSV file. Open the CSV file in Excel. You can see that all the data is here, and this is basic stuff. This is looking at, this is the head of the data frame. This is a short overview of some of the values in the data frame. Then this is how many times each genre pops up, each year, each artist, etc. That's all I was able to do with Python. This is the part I did in R, which is mainly the model and predicting of values. First, right here, we just have setting the working directory. Here is where we set up the data frame. Now, first we read from the CSV file we created with Python and take that into a data frame, which is here. We have, we're just imputing values here. We'll get back to that. Here we're just not including the ID column because we're not going to analyze that. Here we're making sure that the year is a numeric. And then since we didn't input as factors because that messed up a bunch of different things, I go through each field that I want to be a factor and convert it to that. And to also know what the numeric representation of those factors are, I have it printed alongside the numbers here. So going back to this, the reason why I took the value 244, if you can remember from before, the mean time value is 244, so I imputed it as 244 here. Then I split it up into two equal test data frames, one for training, one for validation. Then I built a model to predict the time. Got these following results here. So only really promising ones were at first were mood and theme. Then I narrowed this down and then eventually just became where the theme was the most prominent factor. Then I calculated the average error, and the average error was about 30 seconds off, typically in the downwards direction. So not bad, not terrible. And here we just have a comparison of the values. So these are the actual values, and these are the predicted values from the model here, the generalized linear model. And it looks pretty close to the actual. Of course, it's more constrained towards the mean, but in general, it does do a pretty good job of predicting the time. Thanks for watching. I hope you learned something useful.